Okay everybody, this is video 512. It's our second video for actually the only standard in this unit, and that standard is to describe key graphical characteristics of different functions, which we mostly covered in our first video, 511, and then to perform function operations and function composition, and that's what we're doing right now. Alright, so we're going to start with just different operations. We're going to add, subtract, multiply, and divide any functions that were given to us. So we're going to let f of x equal x squared plus 1 and let g of x equal 3x plus 5. So whatever functions we are presented with, whether they're quadratics like f of x or linear like g of x, we're able to add, subtract, and do all sorts of things with them, and let's go ahead and try that. So for each of the following, we're going to do exactly as it says. And here it says to add f of x, which is x squared plus 1, to g of x, which is 3x plus 5. Now notice I am using parentheses because I want to add these two separate functions together. But because we're just adding, I don't really need the parentheses when I go ahead to follow through on the operation. I'm going to combine like terms. We get x squared plus 3x plus 6. Now f of x plus g of x can also be written as f plus g of x. So that is the same thing, two different ways of writing the same notation. In the next one, we're subtracting. So I'm going to take g of x, which is 3x plus 5, and I'm going to subtract x squared plus 1. So here the parentheses are extremely important because I am subtracting this entire thing. So I'm going to distribute that negative sign, and then I'm going to collect like terms. So this one is going to be a negative x squared plus 3x plus 4. I did write this in standard form, which leads me with the highest exponent first all the way down to the constant. The next one says f times g. So f times g, which could also be written as f of x times g of x. So you notice, and I didn't say that about the subtraction, it can be written similarly to this one. So if this is multiplication, that's exactly what I need to do. I need to multiply the x squared plus 1 times the 3x plus 5. And you may use whatever method of multiplication you would like. I prefer the Punnett square, but you can do other ways. So I'm going to go ahead and write the answer. If you want to pause and then check to see if you get it, that's a good idea. Go ahead and pause now if you want. So you're going to get x squared plus, you're going to get 5x squared. You're going to get 3x cubed, that's a cubed, 3x cubed, plus a 3x and plus a 5. So this is the result of multiplying those two. And again, I write it with the exponent that's the largest first and the constant last. All right, the next one is division. So in this case, I'm just going to type or write down the first function divided by the second function. Because these are two functions being divided by each other, I'm not able to reduce anything, especially in this situation. We're going to have some upcoming ones in future chapters where we could do some reducing, but not in this case. So what we would have to note here is that there is one problem in our denominator, and that we have to state that x cannot equal negative 5/3. So this is kind of like a restriction that we have, because if x equals negative 5/3, we would be dividing by 0. So that's just something to keep in mind. Alright, so the next thing we're going to do is we're going to evaluate. So I'm going to give you the same functions. I've got f of x equals x squared plus 1 and g of x equals 3x plus 5. But this time we're going to be substituting in some numbers. So I want to find f of 1 plus g of 3. So you can do this in parts. You can find out what f of 1 is, you can find out what g of 3 is, and then you can add them together if you'd like. Or you can just write it as a string and substitute in the values when it's appropriate. I'm going to do this one separate, and I'll do the next one in a string. So f of 1 is 1 squared plus 1, which is 2. And g of 3 is 3 times 3 plus 5, which is 14. Because I want f of 1, which is 2, plus g of 3, which is 14, I simply add them together, and my final result is 16. Now the g of negative 6 minus f of 2 is essentially the same thing. I do have to be careful here because I am subtracting. So when I do this one, if you're not careful with the negative sign, then you're not going to subtract it appropriately. So f of 2 is 2 squared plus 1. So now I'm going to evaluate that as negative 18 plus 5. And I can simplify this to 5, and then I get to subtract 5. It is really important. So this one might be better to do as two separate ones and then subtract the values. So this result is negative 18. All right, for multiplication, again, I can write them like this, where it says multiply f times g and then put in 1, or this would mean the same thing. How did that happen? I could also do f of negative 1 times g of negative 1, which might make this a little easier. So f of negative 1 is negative 1 squared plus 1, which is going to be a 2. And then g of negative 1 is 3 times negative 1 plus 5, which is also 2. So 2 times 2 is 4. The last one we have here on this screen is f of 0 divided by g of 0. So once again, you might want to find out what f of 0 is, which is 0 squared plus 1, or 1. And then find out what g of 0 is, which is 3 times 0 plus 5. And then do some division, so I have 1/5 as my result. Alright, so those were function operations because we were merely adding, subtracting, multiplying, and dividing. This time we're going to have to use some function composition, and that is that we're going to be substituting one function into another. And this is some new vocabulary here, the way that this is written. It's pronounced f of g of x. And it can be written two different ways, and I think the second way is actually more clear, but this is the way the book does it. So the second way would be that I want to take f and I want to substitute g of x into it. So it's the second one has to get substituted into the first. Okay, so you're kind of starting at the back and moving in. So if I take g of x and I substitute it into f of x, then this is what I'm going to get. So I will take the g, which in this case is 1/2 x minus 3, and I will substitute that in as in place of the x. So I'm just replacing this x with g. So the entire thing gets substituted, and then I can combine like terms. So this is 1/2 x plus 4. G of f of x means take f of x and put it inside of the g function. So you're substituting in g of f of x, which means f of x goes inside of g. So I take that and I say, well, all right, 1/2, and then I reach the x part, so now I have to substitute in x plus 7 minus 3. So when I distribute, I have 1/2 x plus 7/2 minus 3, and that will simplify to 1/2 x plus 1/2. The next one says take x plus 2, substitute it into g, take that result and substitute it into f. Okay, so when you start at the back, I take x plus 2 and put it into g, get a result. So let's do that. G of x plus 2 is going to be 1/2 times x plus 2 minus a 3, which is 1/2 x plus 1 minus 3, or 1/2 x minus 2. So that's my result of g of x plus 2. And I take that result and I substitute it into the f function, which means that I have 1/2 x minus 2 plus 7, or 1/2 x plus 5. Same thing for this idea. I start in the back, and whatever I get for f of 3x, I put that into g. So I start with f of 3x, which means 3x replaces the x plus 7. That's it. And I take that and I put that into the g function. So I have 1/2 times 3x plus 7 minus 3. That gives me 3/2 x plus 7/2 minus 3. I'm almost running out of room. That should be 3/2 x plus a half. All right, we got one thing left, and that is if there's numbers involved. Well, it's no different. I'm just going to find g of 2 and put that result into f. And so the same thing happens here. Whatever you get for the two that are closest together, that goes inside for the other function. So g of 2 is 5 minus 2 times 2, or 1. And then f of 1, so it's f of the result of that, is 1 squared plus 4, or 5. Let's try the next one. F of 2 is 2 squared plus 4, which is 8. And then g of 8 is 5 minus 2 times 8, or negative 11. This one, you take the result of f of negative 3 and you plug it back into f. So this one, it's harder to write like that, but this is how it'll work. So we'll write f of negative 3, and that will give me negative 3 squared plus 4, which is 9 plus 4 is 13. And then I put in f of 13, which is 13 squared plus 4, which is 169 plus 4, or 173. Our very last one, we're going to put a negative 1 in for g, or in g, and that gives me 5 minus 2 times negative 1, or a 7. And then I do it again with a 7, and I have 5 minus 2 times 7, which is 5 minus 14, a negative 9. All right, there you go.